Alrighty everybody, today I want to go ahead and discuss or review with you all the Unit 2 solo quiz, and it will go over lessons 2.1 and 2.2. So let's go ahead and take a look at all this stuff over here. We have the distance formula. The distance formula says that it is equal to the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. And then here we have something called the midpoint on a coordinate plane, and we've already done something called the midpoint on a number line, where we had to just take the two x values and divide by 2. But on a coordinate plane, you're using a coordinate. It's in the form x comma y, right? So the formula is really capital M is equal to x sub 1 plus x sub 2 all over 2, comma y sub 1 plus y sub 2 all over 2. Okay, and then you close it with the parentheses. And again, that's in the form x comma y. And then here, this is algebra 1 review. We have something called the slope. The slope is the rise over the run, and it's equal to y2 minus y1 all over x2 minus x1. Okay, so let's go ahead and do some example problems so that you're ready for this solo quiz that's going to occur. So yeah, and then we'll talk about parallel and perpendicular later on. Okay, so let's say that I give you 2 points where C is -3, 5, and then we have point D, which is 1, -1. And I say, okay, let's figure out the distance, and then the midpoint formula, and then the slope, okay? What I would recommend that you do is just do the easy ones first, and then the distance formula later. But first, let's go ahead and take a look at these 2 points. I'm gonna go ahead and differentiate them. So here I have my first x, and then this is my second x, right? Yes, these are both x's, but we have to differentiate them. They're different numbers, and they are different points. So we need to differentiate this x. We call this the first x, hence the x sub 1, and we call this the second x, hence the x sub 2. Okay, so if I call this x1, I need to be consistent, and I'm going to call this one over here y1, and over here y2. Okay, super important that you differentiate your x's and y's so that you're able to plug them into the formula. Okay, let's go ahead and find the slope. And remember, the slope formula is y2 minus y1 over x2 minus x1. So if I plug that in, well, y2 is -1 minus, so let me go ahead and just erase that circle. So -1 minus, and then what's the y1? 5. Then I will do the difference of x's. So I have 1, which is my x2, minus my x1 over here. So minus -3. Okay, and remember, when you have a negative times a negative, that's going to become a positive, so keep that in mind. Alright, so let's go ahead and take a look at this. -1 minus 5, I put that in my calculator, that's -6. And again, 1 minus -3, that's basically saying 1 plus 3, so that's going to be 4. Okay, then you look at the fraction and you ask yourself, can I reduce this? Is there a number that goes into -6 and 4 at the same time? Yes, and that is 2. So I'm going to go ahead and simplify or reduce the fraction. Divide by 2 here, divide by 2 here. What am I going to get? I'm going to get -3 over 4. Okay, so -3 over 4. Now what I want to go ahead and do is the midpoint. The midpoint formula is a coordinate point, so you do x sub 1 plus x sub 2 all over 2, then y1 plus y2 all over 2. And then I'm going to go ahead and plug it in. So my x sub 1 is -3, then my x sub 2 is 1. And divide both sides, or not divide both sides, but divide that by 2. Then I will do 5 plus negative 1, which is really 5 minus 1 all over 2. Okay? Then I make this look nicer, so I have negative 3 plus 1, that's going to be negative 2 over 2, comma, 5 minus 1, that's going to be 4 over 2. And then I can't leave my answers like this. I have to look at the fractions, and I got to reduce. So negative 2 over 2, that's going to be negative 1. And then 4 divided by 2, and that's going to be 2. So the midpoint is negative 1 comma 2. Okay? Alrighty. Let's go ahead and do the hardest part of this particular problem. The distance formula is basically the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And this is really the Pythagorean theorem, or really c squared equals a squared plus b squared. Okay? So, let's go ahead and start plugging things in. So, x sub 2 is 1 minus negative 3, close it with the parentheses, plus y2 is negative 1, y1, so negative 1 minus 5, close it with the parentheses, put that square there. Okay, I'm going to go check my work and make sure that everything's all good in the hood. So then I'm going to go ahead and simplify that, because I see that minus or negative and the minus sign right there. I'm going to make that positive. So 1 plus 3 squared plus negative 1 minus 5 squared. Okay? Then what I'm going to go ahead and do is I am going to use my calculator here. This is where you can stop here or you can stop here. But when you're trying to find out what the actual value of the distance is, you got to put this in the calculator, okay? And it's okay to have decimals. Put this in the calculator exactly as you wrote here, okay? So I'm going to pull out my calculator. I'm going to pull out my graphing calculator. And essentially, I'm going to press the button, which is right here. It's going to be second. See how that blue turned into red? I press second, and then I'm going to go ahead and look down and find the button that says x squared. And if you can see, x squared, above that button is that square root sign. So this little thing right here, the square root. So if I can press that x squared button, second x squared, I have that. Okay? Then I'm going to put in the parentheses, and everything has to be inside of that square root. So I have 1 plus 3, close the parentheses, then find the, you're gonna have to find this button. Looks like this. This is the exponent button. Press the exponent button, which is below the clear button, right? And then you're gonna put 2 because that's what we have here. Okay, now to get out of the floating, to get out of the exponent mode, you need to press the right arrow button right here. Okay, if you see that right arrow button, click on it so you can put the plus sign right after. Then put the parentheses again, negative 1 minus 5, close the parentheses, press the exponent button, 2. Okay, now I want you to compare what I have on the calculator, this right here. Compare the one I have on the calculator to this. Does that look the same? Good, it does. So now press enter, and you should, let's see, you should get 7.2 as your answer. So D is equal to 7.2. Okay? And there you go. Hey, there's something that I want to go ahead and note, and that's called rounding, because rounding is going to be, something minor, but it's useful to know in geometry. Rounding, approximation. Y'all, if I say round to the nearest tenth, see that 7.211 in the calculator? What's going to happen here is if I ask you, round to the nearest tenth, well, here is 7.211. This is the tenths place. That 2 carries the tenths place. And the number after that is going to dictate what's going to happen to that 2. Okay? So if it's 0, 1, 2, 3, 4, if this number was 0, 1, 2, 3, 4, then this number doesn't change whatsoever, and the answer is just 7.2. But if this, let's say if I change that 1 to a 5, well, if it's 5, 6, 7, 8, and so on and so forth, then this number does change that to, and it's going to increase by 1, so the answer would be 7.3. Okay, just to let you know when it comes to rounding. Alrighty, now what I want to go ahead and do is talk about slopes of parallel and perpendicular lines. So when one line is parallel to another line, then they have the same slope. Okay, for instance, if I have one line with slope of 2/5, then that other line parallel to that original line is also 2/5 in terms of the slope. So again, if my original slope is 2/5, then that line parallel to the first line is also going to be 2/5. So the numbers don't change at all, or the fraction or the slope doesn't change whatsoever. Then if I say, okay, well, if I say one line is perpendicular to another line, then they have opposite reciprocals, which means opposite sign, flip the fraction. So if my original slope is positive, then the slope is going to now turn into a negative for that other line, okay? Or if it's negative, then it's going to become, if it becomes negative, then it's going to become positive, right? And then you have to flip the fraction. So let's go ahead and take a look at this. This is my original slope, which is a positive 2/5. If I say perpendicular, then that means I need to change this plus sign to a negative, and then I flip the fraction so that 2/5, well, the 2 is now going to become in the denominator, and that 5 is going to become the numerator, okay? So positive to negative, then flip the fraction. Or vice versa. If this is your original slope, you need to make this negative become positive, and then you flip the fraction here, okay? Change sign to opposite, opposite sign, flip fraction. All those things are going to be super helpful to know when you're doing these perpendicular problems. Let's go ahead and take a look at some examples here. So let's say I give you this question. Determine, and I pull this question from the notes. Determine if parallel, perpendicular, or neither. And you have point X, which is 3, 1, point Y, which will be -4, 2, point A, which is 4, 10, and then point B, 3, 3. Okay, your goal here is to find the slope of X, Y, and then your goal here is to find the slope of AB. Okay, and remember the slope formula is this: it's m equals y2 minus y1 over x2 minus x1. So let's go ahead and look at x, y. So here's x and here's y. So what's the slope using these 2 points here? So the first thing that I would like you to do is the label. So x1, x2, and then this becomes y1, y2. So let's go ahead and plug it in. So y2 is 2. This is 2 minus 1 all over -4 minus 3. Okay, so again, this is my y2 minus my y1, and this is my x2 minus my x1. So now I'm going to go ahead and figure out what's the top and bottom. 2 minus 1, that's 1, and then -4 minus 3, that's -7. Okay, so the slope of xy is 1 comma -7. Now, I want to figure out what the slope of AB is. So again, I want to label. I'll call this x1, x1, x2, y1, y2. So then, plugging these in to that, I have, well, y2 is 3 minus my y1, 3 minus 10, okay? Let me see if I got this right. 4, 10, 3, 3. I'm just looking at my notes. Okay. So then I do x2 minus x1. So that's going to be 3 minus 4. And y'all, 3 minus 10, that's going to be -7. And 3 minus 4, that's going to become -1. And look at that. I have a negative divided by a negative. I have to simplify, make it look nice. Perform all operations until I no longer can. So I have 7 over 1. Okay? So if I compare this slope to this, what can you say? Is it parallel, perpendicular, or neither? And the answer here is, okay, well, if I look at my original slope here, we'll call this my original slope. Okay? Here's my negative, this is positive, and I notice that the fraction is flipped. And if the fraction is flipped, then the answer is perpendicular. Or you can just write the word perpendicular. Okay? Alrighty. Now, just last thing. If I said that, well, what happens if you get this? If the slope of xy is 7 and the slope of AB is also 7, what do you say then? Well, you would say it's parallel, right? You would say that those are parallel. Or if you have something like this, the slope of xy is 7 and the slope of AB is 3, then what can you say about the slopes? They are neither. Okay? Just in case something pops up like that. Okay, bye-bye.